Okay, here's the several problems now again with section 2, and it's a lot more exponent type of stuff. And it's all the same properties that we've talked about before with exponents. None of the properties have changed. However, quick glance will show you that we are dealing now with properties that have rational exponents, fraction exponents. So these are going to be a little bit more challenging to work with only because you can't quite add or subtract fractions as quickly as you can an integer number. But that's okay, it's no problem. So it's the same rule as before. If the bases are the same, you add the exponent. And you're multiplying, you add the exponent. Well, here I've got the same bases. I'm multiplying, I'm going to add the exponent. So this is going to be 5 to the 1/2 plus 3/2 power, which is 5 to the 4/2 power, which is 5 squared, which is 25. Now, I showed a lot of steps right here, but it's important that you see these steps because if you can just take one step at a time, very seldom will you make a large mistake. All right, the next question, just like before, if I had numbers inside parentheses and an exponent outside, the two exponents multiply together. Okay, same thing now. I've got 3 to the 5/2 inside, so what if I've got 3 to the 5/2 times 2 over 1 power, which is the same thing as 3 to the 10/2 power, which is the same thing as 3 to the 5th power. And if you want to work that out, you can. 3 to the 5th power is one that you should be able to do without a lot of pain and suffering, but it's just 3 times itself 5 times. It's going to end up being 243. And if you don't have that memorized yet, that's okay. You'll get it. Just hang in there. All right, the next one is if you've got two numbers with an exponent outside, then that exponent goes to both guys on the inside. You multiply it all the way through. So it's just like what you did in previous times. Well, what do you have? You've got 16 to the 1/2 power times 9 to the 1/2 power. Well, remember that we've learned that the 1/2 power is the same thing as the square root. So the square root of 16 is 4 times the square root of 9, which is 3. So this guy is going to equal 12. All right, and that's it. Don't let this be horrible. Looking at the next guy, you've got a negative exponent. Well, what happens if you have a negative exponent? It goes from the numerator to the denominator. Okay, it goes from the numerator to the denominator. So if I've got 36 to the negative 1/2, what I really have is 1 over 36 to the 1/2. And just like in the example right above this, if I've got an exponent of 1/2, that's the same thing as the square root. So this is really the square root of 36, which is just 6. All right, another one that we're looking at here is if I've got the bases are the same, then and a fraction, then I subtract the exponents. If the bases are the same and they're a fraction, subtract the exponents. Well, I've got the same bases here, so I've got 4 and 4, and since I've got 4 and I've got 4, my base has to stay 4, and then I just do the top minus the bottom, so that's going to be 5/2 minus 1/2. And what is this? This is the same thing as 4 to the 4/2 power, which is the same thing as 4 squared, which is the same thing as 16. When do you stop on all this? You stop when you get down to that one integer number. Or if you end up with something like, say, 5 to the 8th power, you don't need to multiply out 5 to the 8th power. Leave it as 5 to the 8th. But if it's one that we can do, 3 to the 5th is in the range of things that we can do, then you do it. And then just like the previous problem that we saw up here, these two guys are really closely related. Now they're just dividing instead of multiplying. So this fraction exponent on the outside has to go to each number on the inside. And so what does that mean for us? It means that we're going to have 27 to the 1/3 power divided by 64 to the 1/3 power. And we've learned that 1/3 is a cube root. So the cube root of 27 is 3. The cube root of 64 is 4. And I'm done. So these powers take a little getting used to, but they're not new. They're old. They're ones that we've seen before, but these fractions now, they're what's going to make things kind of difficult. So pay attention to what you're doing and make sure you add or subtract correctly. You can also punch this into your calculator and see that you're getting the right numbers, and that will help you too. Okay, now let's talk about radicals a little bit more in detail. So some properties. If I'm multiplying two numbers inside the radical, then it's the same thing as multiplying each independent radical by that number underneath. So if I've got something like, say, the cube root of 12 times the cube root of 18, what do I really have? Well, what I really have is the cube root of 18 times 12. Okay, I really have the cube root of 18 times 12. And so when you do that, what is this really? Well, go ahead and multiply 18 times 12. And you're going to find out that this is going to be 216. And the cube root of 216, we've done this in a previous problem, in the previous section, and so the cube root of 216 is going to be 6. And if you can't remember, then factor tree that guy out. And remember, it takes 3 of something to bring one item out. And look at the 21 and the 6. That's a number divisible by both 6, or by 2 and 3, so it's divisible by 6. 6 goes into 21 3 times 18, and that leaves us with 36 left over, which is going to be 6. And so looky here, 6 and 6, and I need a group of 3, and I've got my group of 3. Okay, so it looks different, but it's true. I'm telling you, it's good. What about this guy? Well, this is actually the 4th root of 80 divided by 5. And 80 divided by 5 is a lot easier to work with than these two separate 4th roots. So what have I got? Well, what is 80 divided by 5? Because that's what I'm going to end up with. The 4th root of, excuse me, 16. Well, what is the 4th root of 16? If you can't remember, run over here and make a factor tree real quick. 16 is made up by 4 and 4. Both of those are made up by 2's. What number do I have 4 of? Because that's my answer. And the answer is 2. Well, what about this last guy here, the 5th root of 7 and the 5th root of 8? So what do you? How does this guy work out? This is going to end up being the 5th root of 7/8, and hey, guess what? We're done. That's all that guy would end up looking like. Okay, now the drawback to this guy that we just answered out is that some teachers, some math people, really don't like to have a radical in the denominator. Like we've got this 5th root of 8, which is what we have in our answer. And so what they would do is they would eliminate that radical. Okay, so let's look at that real quick. The 5th root of 7, we'll leave it alone for just a second. Okay, we'll come back to it in just a minute. Now, the 5th root of 8, though, what is 8? What is 8? 8 is 2 times 2 times 2, right? Which is 2 to the 3rd power. So I need how many more 2's down here? I need how many more 2's down here in order to get 5 2's? Well, I need 2 of them. And so what I'm going to do is I'm going to multiply the top and bottom by the 5th root of 4, because that's what 2 2's are, the 5th root of 4. And so I'm kind of following that very first rule, and when I do that, I multiply by the top and bottom, and what I end up with then is the 5th root of 28, and this is okay, over the 5th root of 32. And we've learned in a previous lesson that the 5th root of 32 is just a 2. So if you're taking a standardized test, probably, most likely, but not guaranteed, that your answer is going to look like this right here. This answer is not incorrect in a lot of places, but in some places it is. So we need to be able to do both. We need to be able to clean up that radical underneath. But that's all there is to it. Don't let this be a horrible thing. However, getting that radical off the bottom can be tricky, so just pay attention to what you're doing. All right, even more radicals. How fun for you. Well, what I've got here is I've got the fourth root of 10, a fourth root of 10, and 7 fourth roots of 10. So if I have 1 fourth root of 10 plus 7 fourth roots of 10, how many fourth roots of 10 do I have? And the answer is I've got 8 fourth roots of 10. Just think you're going shopping at Walmart, okay? And you're picking up one fourth root of 10 and decide you need 7 more. If I've got 1 and I add 7, what do I have? I've got 8. Same thing on this next question right here. I've got 2 8s to the 1/5 power, and I've got 10 8s to the 1/5 power. What do I have? I've got 2 plus 10 eighths to the 1/5 power. Well, what is that really? 12 times 8 to the 1/5 power. Now, you cannot come through here and say this is 96 to the 1/5 power. This is not true. Don't do this. It's wrong. It'll mess up your test grade. It'll mess up your homework grade. Don't do this. It's not correct at all. So just leave it as 12 times 8 to the 1/5 power. Well, what about this bottom guy down here? I got the cube root of 54 and the cube root of 2. Well, those aren't the same guy. So I can't combine them how they're written. But I can simplify or look for ways to simplify 54. 2 doesn't simplify. 54 might. So I take my 54 and I start thinking about what numbers go into 54. And this is going to be 9 and 6. And it's going to be 3 and 2 and 3 and 3. Now, when dealing with the cube root, it takes 3 to bring out 1. And so what I really am working with here is 3 cube roots of 2 minus the cube root of 2. Well, if I have 3 cube roots of 2 and I take away 1 cube root of 2, then I'm actually working with 2 cube roots of 2. Okay? And again, don't let this be hard. Follow your intuition on this. If I've got 1 of one specific item and I add 3 more to it, then I've got 4 of that item. And it just so happens to be that on this particular type of a problem, all our items are rational exponents. Okay? So again, don't panic. Don't make it hard. Just relax and follow your intuition. Okay, a couple of other things to talk about that can be really tricky with radicals is when that nth power is even or odd. And so some rules. When n is even, when n is odd, okay, notice that x to the n of the nth power, that's just plain old x, okay? But when that power is odd, there's only one answer that you can get, okay? There's only one answer that you can get, and that answer is the number that's under the radical. In this case, it would just be a straight up 5. If I look at the other version of that, if I look at -7, or if I look the 7th root of -5 to the 7th power, there's only one answer for this, and it's -5, okay? And so when the n's are odd, you just get whatever your answer is, okay? But when n's are even, you get absolute value, and that's different, and it's hard sometimes to catch, so you really have to pay attention. And here's why. When I take the 4th root of 3 to the 4th, I get 3. But also think about this. When I take the 4th root of -3 to the 4th, okay, when I do this, I still get a 3, okay? So it doesn't matter what number's on the inside, whether it's a 3 or -3. It doesn't matter what that number is. I get a +3 as my answer. And why? Well, think about this for 1 second. If I have 3 to the 4th power, that's the same thing as saying 3 times 3 times 3 times 3. Okay? Well, that's going to be 81. If I have negative 3 to the 4th power, that's like saying negative 3 times negative 3 times negative 3 times negative 3. Well, what is that? That also is positive 81. Both numbers equal the same thing. So when we look at even powers of n, we need to look at the absolute value of the number under the radical. Even more radicals, so even more things to work on. With these radicals, we've got a lot of different things that are going on here, and so let's just start working them out. And the whole clue on all of these is, what root are you looking for? Because whatever your root is, that's the number of items that you have to take out, the number of items you have to have before you can take one thing out. So you've got to know what your root is, and then you just work from there. So 64, the cube root of 64. Well, what numbers go into 64? All right, and that's going to be 16 and 4, and 4 and 4. So what do you have 3 of? Well, you've got 3 4s. Okay. What about y to the 6th? Well, how many y's to the 6th, groups of 3 of y to the 6th do you have? And the answer is, with that 6, I've got 2 groups of y to the 3. So I can bring, this guy right here is actually really nice. He turns out to be 4y squared. That's it. That's it. That's my answer. Well, look over here at this next guy. How many different, what, 4, let's just look at it. 4 breaks down to 2 times 2. Okay, big deal. 4 breaks down to 2 times 2. Well, how can I handle that? Well, I don't have 5 2s, so the 4 is going to stay under the radical, okay? So I'm going to have a 4. Now, I've got a to the 8th. So if I have 8, how many groups of 5 can come out of that? And the answer is 1 group of 5. And when I take my 1 group of 5 out, what's left? A 3. So this is going to be a cubed. What about b to the 14th? How many groups of 5 can I get from that? And the answer is, I can get 2 groups of 5. That's going to be 10. So when I do that, what's left? A 4. So this is going to be b to the 4th. And then the last one is the c. And how many groups of 5 do I get from c to the 5th? And the answer is 1. And that takes out my 1c. And that's it. I'm done. Everything is out. So that's all there is to it. Well, what about m to the 4th and n to the 8th? M to the 4th and n to the 8th. Well, my m to the 4th, if you'll notice, they're a positive and a positive, and they're both evens. So I've got 4 of those guys. So when I pull that m out, I'm going to need the absolute value of m, okay, divided by the same thing for the 8. Now I've got n to the 8th in here. So how many groups of 4 do I have? And the answer is, I've got 2. So this is going to be n squared. And that's it. That's all you can do on that guy. What about the cube root of x over y to the 8th? The cube root of x over y to the 8th. Well, again, we're looking at not having a radical in the denominator. And in order to avoid that, I really need this to be a number that's divisible by 3. And I can't go smaller than 8. So the next possible choice is to make it a 9. So to do that, I'm going to multiply the top and the bottom by a y. What this gives me is a new question, the cube root of xy over y to the 9th. Now, look at this. This is really nice. How many groups of 3 are in y to the 9th? And the answer is 3 of them. And then how many groups of 3 are in, do we have for x's and y's? And the answer is no groups of 3's. So I'm left with the cube root of x and y on the top. All right. What about this 14xy cubed over 2x to the 3/4 z to the -6? Well, on this guy, match things up that are the same. So for this particular guy, we can look at 2 and 14. We can look at x's. Whoops, that's fat x. I need thin x. Let's see. I need my thin marker. And then we can look at y's. And then we can look at z's. Okay? And so that's how we're going to compare these guys. So when we work it out, go ahead and reduce. 14 over 2, that reduces to 7. And then x is going to be, that's first power there. It's x to the first power, even though we don't see it. That's what it is. And so it's going to be x to the 1 minus 3/4. There's nothing else that goes with y. So y is going to be 1 to the 1/3 power. And there's nothing else that goes with z. But z's got a negative exponent. And so to make that exponent positive, we move it to the numerator, which just makes it straight up z to the 6th. So what looked like a really nasty looking problem turns out to just be pretty simple. 7x to the 1/4, y to the 1/3, z to the 6th. And that's it. These problems can get really complex. Break it down into little bite-sized chunks and work at one little piece at a time.